Hello everyone, and now we're going to be going into example 9-15. Okay, in this example we're going to hit on shear strain. Now I do have a bone to pick with your book in that their notation is horrendous. So your book says that this is the symbol for shear strain, but everybody else, let's make sure that I don't mess up everything terribly for you. It's been a while. Yes, is going to be using this symbol, okay? So don't forget this. Everything else is fine, but this is usually the symbol for shear strain. Doesn't matter too much, and I'm not going to fault you if you use either one, but that's honestly what everybody else uses. Okay, now it's talking about this example. It's taken from the book, and what we have is we have a block. And it originally looks like this. And then after we apply some load to it, it gets sheared. It gets sheared to the side. It gets kind of twisted. And you see that it's gotten longer along this direction. It's gotten shorter along this one. And so we have some displacement here at the top, which is called delta S. And we have an original height right here, which is the length. And we have an angle. Angle's not super important in this particular problem. And we have an applied load P. Now what it tells us in this problem is that we're assuming that the displacement is 0.0024 inches. And the height of the block is 1.4 inches to begin with. And it says, what is the shear strain? So given that delta S is equal to 0.0024 inches, and that the height is equal to 1.4 inches. What is the shear strain? So we're going to write it down. Find. We use either. I'm going to use this symbol because I'm a notation fanatic, and we'll go from there. Now let's not write down our shear strain equation. So it looks something like this for your book. It says this. And what I'm going to write is just slightly different. I'm going to write it like this. Same equation, just different notation. And then I know everything I need. I know what the displacement is, I know what the length is, and so I can solve. But kind of notice here that the length in this case was the height, not this value down here. Be very careful about this. Not this, this. Okay, and I plug in my values and I get 0.0024 inches on the top. 1.4 inches on the bottom, inches per inch. So it's unitless, the units cancel if I wanted to. And what I get is that the shear strain is going to be equal to 0.0017 inch per inch. And I am done. That is the strain. What this is this is a fraction. If I multiply this by 100, it says that it had an elongation of 0.17%. 0.17, so a tiny amount of elongation. But we don't expect big numbers when it comes to strain. If you see 50% or even 10%, honestly, you should be worried. That's kind of huge. So, this is the end of example 9-15, and I hope it helped you, and I will see you guys later for the next example. Have a wonderful day.